Okay, so this data logger may look complicated to you to assemble, for example. So how do you get started even? Let's remove this assembled version. I have a component version. So this one has components tied down with rubber bands. Apparently, rubber bands are pretty easy to secure the components. There's only one or two things you want to look out for. You have to tension the rubber bands enough so that they actually hold the components down while you solder. Otherwise, the components won't really look that good. They will actually be tilted or not secure to the board, against the board. And also, the second thing is the rubber bands, you have to tension them correctly. For example, this power switch here is I intentionally tensioned it wrong, so it's tilted. So how do you do it? Well, you just have to tension it by pulling on the rubber band, and just by tensioning it correctly, now it is actually nice enough. So once you solder, you see, oh, this looks nice instead of tilted. I did this with all the components that could tilt already. So the reason that this board being called TH is through hole. Through hole means components are they have these pins that are pushed through these holes. They're soldered on the backside. So all soldering actually occurs on the backside of this board. So with these groups of components, as you can see on the backside, there are lots of pins that are sticking against the backside. That includes these resistors pins that are soft enough you can bend them apart so they don't fall out. You don't really have to get them extremely secure, just to have to make sure they don't fall out. And that's the fuse, and this is a transistor. Just bend the pins so the components don't fall out. And these are pins from the screw terminal blocks. What I would do is I would tack solder, just solder one pin, solder the opposite pin, and then I can remove the rubber band if I want, because the rubber band is in the way of one or two pins. You don't want to solder with the rubber band next to those pins. So that's how you prepare the board. This is typically 25% of the soldering job is all these. The screw terminal blocks, some resistors, a header for the display, a fuse, this is a speaker, a transistor, and this power button. And another 25% of the soldering would be the display's backpack. Sometimes these displays don't come with the backpacks pre-assembled, so you'll have to solder these pins to the backpack, these pins to the backpack, make sure these pins are actually facing away from the backpack, and then solder the backpack against the display. So that would be roughly 25% of the assembly work. I would recommend, if you're a beginner, you start soldering this first, so that it would be easier. You won't ruin an entire board. If you just solder these pins, you can still fix them easily. So altogether, this represents 50% of the assembly work. And the other 50% will be here. Soldering the Arduino Nano onto the board is roughly 25% of the work because of the number of pins you have to solder on the back side. But this is more or less repetitive. You don't really have to prepare the board so extensively. You just push this Arduino Nano onto the board and start soldering the back side, and make sure that you don't create jumpers or short circuits with your solder. There are a few places that you could potentially create short circuits. So let's get them close. And here's one spot. As you can see, these bigger holes, these are for the Arduino Nano's pin. And there's a smaller hole. This is a via. And make sure you don't jumper wire these two together or short circuit these two together. There's a second spot, is right here. And make sure you don't use excessive solder on these two holes to somehow short circuit with that hole. And the rest of them are not that difficult to solder. So the last 25% of solder will be, for example, this is the SD card slots connector, and this one is just a stand. So the SD card connector, this entire board will not bend downward. If that happens, the metal SD card holder will likely short circuit the power switch here. So I built this in here so that once you have your SD card on, there's no way to push it downward to make any kind of short circuit. And that's part of the last 25% of the soldering. And the rotary encoder should go on last because it's so long, and once it's soldered, the board doesn't really stand on its backside. It doesn't really stand well on the backside because there's such a long shaft there. And the last 25% also includes soldering the real-time clock on, and one of these two power supplies. So depending on what you have at hand, and then these two pins are for the battery compartment. So you can look on the back side or the front side which pin is the positive. The positive goes with the red, the negative goes with the black. That would be it. So if you're pretty good at soldering circuits, this will take you maybe 25 minutes to complete. But if you're a beginner, this may take a whole hour, but that's only because you're just learning how to solder for the first time. But then typically if you want to solder a second set, this would take you less time, maybe not half the time, but quite a bit less already. So that's the purpose of this, is to make sure that open source electronics can be done by people that are interested, but that those that don't really have skills to assemble surface mount components, such as this board. This is an Arduino Mega. As you can see, this chip will be pretty difficult to solder on, and in a different version of a data logger, I do have chips like that that are surface mount on both sides of the board. So it is relatively difficult for a hobby electronics person to actually do that kind of soldering. But this is entry level, and you can basically teach yourself how to solder and then start assembling this. Thanks.